This video is a brief introduction to analysing a continuous beam in multiframe. We'll start by using the generate command to generate a 5-span continuous beam with the length of each span being 3 meters. Some default restraints are applied, but I'm going to change those. I'm going to change the left-hand end restraint to pinned, and I'm going to select the remaining nodes along the beam and make them on pinned rollers. I also need to set the section type, so I'll select all of those members and use the section command to choose a section from the library. This is an American library. I can use any library that I wish. Let's just check that in 3D, make sure it's okay, and then move over to the load window. This is my first load case. I'm going to look at loads on alternating spans. I'll choose a distributed load, I choose the load direction, the load magnitude, and the shape of the load. I can then add another load case. I'll add a second load case, and this time I'll choose the other alternating spans, but I'll use the same load. And for load case 4, I'm going to do the same thing, but this time I'm going to use point loads. So I'm going to use a point load on the members and put those at the middle of those spans. And for load case 4, I'll do the same thing on the alternating spans. So I'll just invert the selection, choose the point load, and apply that. I'll carry out a linear analysis and then move over to the results window and take a look at the results in terms of the bending moment diagram, shear force diagram, and deflected shape. This is all for load case 4. Let's go back to load case 1, and we can step through load case 2, load case 3, and load case 4 to compare the different diagrams. I can double click on an individual span and take a look at the local results on that particular span, or I can group all the members together for design purposes and group them as one design member. In that case, if I double click on them, we'll see all of the values together along the length of the continuous beam. That completes our introduction to continuous beam analysis. Thank you for watching.